Anyone can walk into a hardware store today, buy a device meant to rip through solid oak, and plug it in on their kitchen counter. Modern DIY culture has put industrial-grade equipment into millions of untrained hands. And because these devices often share the ergonomic design of simple manual tools, we naturally assume we can handle them the same way. A handsaw relies entirely on the strength of your arm, but a circular saw houses a 15-amp motor spinning a steel disc at 5,000 revolutions per minute. At those speeds, the motor is indifferent to whether it is encountering pine, hardwood, or human bone. It only knows how to apply extreme torque to whatever stands in its path. When catastrophic injuries happen on a job site, they rarely occur because the machine physically broke down. They happen because the user misunderstood the physical boundaries of the tool. This 3D spatial map shows a spinning saw blade surrounded by overlapping color-coded threat zones. These zones represent the actual cut path, the protective barriers of the safety guards, and the strictly defined spaces for safe hand placement. We call this the geometry of danger. Memorizing and respecting this invisible geometry is the singular difference between a successful weekend project and a catastrophic amputation. The primary geometric rule of using any power tool is absolute. Your flesh must never intersect or align with the tool's intended cut path. Beginners often violate this rule. They try to guide wood through a table saw entirely by hand, without a fence, or reach directly behind a spinning blade to pull a small offcut from the table. Those subtle off-axis pressures cause the wood to twist slightly. This overhead schematic illustrates binding. As the wood pinches the blade, friction builds up instantly. Kinetic energy is suddenly reversed, launching the wood backward. This violent lever yanks the user's bracing hands forward, dragging them directly into the spinning teeth. Spatial danger also exists inside the wood itself. If you fire a brad nailer into a piece of trim and the nail strikes a dense knot or a hidden ring in the grain, the flexible metal can instantly deflect. It will curl and punch right out the side of the board, directly into the hand you're using to brace the material. The cut path is a volatile zone. Engineered rotational forces will instantly overpower human grip and reaction time. Danger isn't confined to the cutting edge of a tool. Severe physical threats exist right where you grip the machine. People tend to view power drills as harmless because there's no exposed blade. They assume their own wrist strength can withstand the rotational force of the electric motor. Then they attach a large diameter bit, like a hole saw, and push it into dense material. If the teeth bite too aggressively and jam, the bit seizes completely. Because the bit seizes, the motor's energy searches for an exit. Instantly, the heavy drill body violently twists sideways against the user's locked wrist. Surviving this battle of torque requires expanding your geometric control points. By utilizing side handle attachments and bracing with both arms, you rely on mechanical leverage rather than raw physical strength to absorb the shock. Riving knives, rip fences, and spring-loaded blade guards exist for one specific purpose. They are engineered physical boundaries designed to enforce safe geometry. Yet, a common sin in home garages is actively removing this geometry for convenience. Professionals and beginners alike will often use a wedge to pin back the blade guard on a circular saw, completely exposing the teeth. When you finish a cut with a pinned guard, that blade is still spinning at thousands of RPMs. If you absent-mindedly set the tool down on a flat surface, you unleash a latent kinetic threat. This side profile diagram shows those circular saw teeth making contact with a flat surface. The moment the spinning steel bites in, it acts exactly like a rubber tire on pavement, propelling the heavy tool rapidly across the floor toward the user's feet. Bypassing engineered safety gear actively weaponizes the machine's stored kinetic energy against the user. We have to stop looking at power tools as heavy hand tools. Pulling the trigger on a saw or a drill unleashes a caged physical reaction that must be managed through friction, torque, and leverage. Human reflexes are too slow to counter the chaotic physics of a machine spinning at 5,000 RPMs. Once a bind occurs, the reaction is already over before your brain registers the danger. The only solution is a complete mindset shift. Operating these machines requires an absolute, non-negotiable discipline of checking your physical boundaries and hand placements before the motor is ever engaged. True proficiency in a workshop comes down to respecting the machine's geometry. Let the engineered armor do its job, clear the cut path, and always prioritize the safety of your hands above the speed of your work.